Imagine that you are building a model rocket for science, and it is time to test the launch. You and your group go to the middle of the football field and launch the rocket. Your group records the data of the rocket's elevation in meters and the duration of the launch in seconds. So here's the data, the height of the rocket that is above the ground, this many meters at these times. The time is the input and the height is the output, because the height of the rocket depends on the time since the rocket was launched. Now we're going to write down the quadratic function produced by quadratic regression round to the nearest two places. Now you need to do some setup on your calculator before you do this. You should go to y equals, and if there's anything in y equals, you should clear it out. You need to make sure that your plot 1 is on, and if you go to second and y equals, you get to stat plot, and you want to make sure that it's on. You want to make sure that it's the first type, that the x list is list 1, the y list is list 2, is L2, and then the mark is the little square box. Then you want to go to stat, and you want to go to edit, and in this case I'm not going to do this step because I don't want to clear all this information since I already put it in for the problem in class. But if you have information from other classes, you would have to go to the highlight, the list, and then hit clear. Do not hit delete. If you hit delete, then you're going to delete the entire list, and that's a very frustrating process to try to get the list back. Okay? Alternately, you could go to stat, and then you could go down to clear list, and then type in the lists on the home screen with a comma in between each of the lists that need to be cleared. And finally, the other way you could do it is you could go to second and plus, which is going to give you the memory, and you can go down to floor and it'll clear all lists. So going to stat and edit, after you've cleared these lists, you enter in the data, and notice that I've put in the time since the rocket was launched in list 1, and the height above the ground in meters in list 2. Now in order to be able to see this on the graph, I'm going to have to adjust the window, and here you can see that I've adjusted the window. The input is below the lowest input at 0, and the reason why I put at least the input at 0 was because I want to see the origin on the graph. And the max is just above where it is, so I can see all of my points within the graph. The y min, this time I put at -5 because I know I'm going to want to know what the zeros are of the situation. So I want it to be below y equals 0, that y-axis, and the max has to be above the greatest point. Now, in previous situations, like a linear situation, usually your last or your first is your greatest, but in this case, it's one of your middle ones. So you want to make sure when you're doing this in other situations that you don't want to, you're not going to want to get the wrong max in here. You want to use the max that truly is the maximum output data point. Okay, when we graph this, it gets this nice looking parabola that we'll be showing. So you can kind of see the trend. Now let's talk about actually finding the function. Now remember that the quadratic regression process helps you find the function that will represent the data. Find the function that will represent the data so that you can take any given input, like let's say we have like time equals 4, plug it in, and you would get an estimated value for the height of the rocket after 4 seconds. 4 seconds was not part of your data. There's a lot of missing data in here because the launch goes by so quickly you can't really take that much information in that. So this gives you an idea of what the trend would be, and then you use the function to fill in the gaps, so to speak. So in order to do this, you have to press stat. Then go over to calc. Then go down to 5. Quadratic regression, or quadreg. Choose that. You're going to come up with the menu. Go to Store, Reg EQ, and you're going to press vars, which stands for variables. Then select yvars. Then choose function. Then y1. So when you calculate, you can write down your function by rounding to the nearest two places. So we're going to say y equals negative 1.37x squared plus 35.12x minus 25.63. The only reason why I say to the nearest two places, you don't really put this function anywhere else, because if you did it all correctly, then your function will already be in y1. So let's check that. And voila, we have it here. This is our regression function. See, it's automatically stored in there by doing the store reg EQ, vars, yvars, function y1. This stores your function into y1. Okay, so now if you graph it, you're going to see then the parabola of the function forming that goes through the data points. It's not going to go exactly through every single data point, because remember, this is a regression. The other thing that's not going to happen is that it's not going to line up perfectly with the with 0, 0, like unless you actually have maybe one of the data points is 0, 0, then that would change it. Okay. Now, let's see if we can use the function that we've stored into y1 to help us find the rest of the information. According to the function, what is the greatest distance above the ground the rocket has ever reached? So in this case, we're looking for the vertex. And in the case of the graph, that's going to be what's called the maximum. So you're going to go to second trace, which is going to give you the blue calculate menu. You're going to go down to maximum, and then it's going to ask for a left bound. Now, the left bound is going to be to the left of the highest thing, and you can just see the cursor flashing right above there. If you want to, you can go to your window, I'm sorry, I'm shouting, and increase the Y max. So then when you go to your blue calculate and for the maximum, then your cursor is not right over your function. It's a little bit easier to see. So that's a good left bound because it's to the left of the maximum point, the point that has the greatest output value, and then just choose one to the right, and then we're going to guess that. So our maximum, let's just write down this data and we're going to interpret it. So y equals 12.8, let's say, or x equals 12.8, and y equals 198.8. Okay, so let's look here. According to the function, not the data, according to the function, what was the greatest distance above the ground that the rocket ever reached? So in this case, at approximately, let's say 13 seconds, we're just rounding to the nearest second, the rocket reached 198.8 meters. So that was the highest that it was, because when we looked at our function, this was the point 12.8, 198.8. According to the function, what was the height of the rocket above the ground before it was launched? Now, I told you guys to actually not worry about this one, because actually according to our function, if we look at our function back here, that would be what our y is for the ground before it was launched, when our x is equal, or when x is like -1. But if we looked at our function, we would see that this never actually gets to 0, 0, or it doesn't intersect up at a height. It actually would intersect below. So I just had you guys cross that one out. How long did it take for the, until the rocket hit the ground after being launched? Now this is going to be what our second 0 is here. So according to this, it looks like I'm kind of getting right up against the line there. So I'm going to want to go back to my window, and I want to increase this maybe to 50. And then I can see my second 0. Then I'm going to go to second trace, which is going to give me the blue calculate. I'm going to calculate my 0. And I want to calculate this second one, because this first one is when it was launched. Wait, I lost my cursor. Okay, there it is. Okay. So I'm just doing the same thing that we did before when we were finding the zeros. Okay. So we get that x is equal to 24 and y is basically equal to 0. See how it says -2 e to the -11? That's like -2 times 10 to the -11. That's basically 0, okay? Don't ask me why the calculator does that. I didn't program the calculator. According to the function, what was the height of the rocket above the ground before it, sorry, that was the wrong one. How long did it take for the rocket to hit the ground after being launched? It took the rocket 24 seconds to hit the ground. How much time had gone by when the rocket was 180 meters above the ground? So we're going to go back to our calculator, and basically what this is saying is y equals 180. And in this case, we're going to plug in 180 into our y2. And then we're going to find the intersection. Now look, there's actually 2 intersections here because we have a parabola. Okay? And so we're going to go to calculate, we're going to go to intersect, and we're going to say the first curve, second curve, and then we're going to go and scroll over so that our cursor is almost on the first intersection, and we're going to have it guess. I'm just going to record this data and I'm going to interpret it later. Okay, so x equals that. And now I'm going to find my second intersection. So second trace, intersect, first curve is that, second curve is that. I'm going to go over to my second intersection, hit enter, and that's going to be 16.49. So now what this is telling me is that when the rocket was 180 meters above the ground, so if I'm just going to sketch a rough sketch here of my graph, okay? When my rocket was 180 meters off the ground, there was actually 2 times it was 180 meters off the ground. When it was being launched and then when it was coming back down again. 9 seconds and 16.5 seconds. So this gives you an idea